quick algebraic method. Some students get really flustered in situations like this. Velocity is equal to the distance you go divided by the time you take to get there. That's what your speed or velocity is. And they're given usually, someone gives you distance and time, no problem. You take the distance, divide by the time. But every once in a while, especially teachers will always love to do this, if you're told someone is going 120 meters per second, and they went a distance of 45 meters, and you're asked to find out how much time in seconds did they take. And you'll be flustered. And the pyramid explanation I sent last time solves this, but I also want you to ask yourself, when you have a situation where the variable you're looking for is at the denominator, how do you solve it? It must end up on the numerator in order to solve it. And you can't just slide it up. So here's the algebraic solution. You're allowed to do anything mathematically, even in physics equations, as long as you do it to both sides of the equation. If I multiply by time on this right side, I must therefore multiply by time on this left side. I'm left with 2 t's on the right side, one on the numerator and one on the denominator. And when everything is multiplying and dividing, and you have something on the numerator and something on the denominator, they can cancel out. As long as there's no plus symbol here, d plus t, you can't cancel. But because they're multiplying and dividing, those cancel. And now we have the beautiful situation where the t is on the numerator, but it's being bothered by that v. So a lot of people say divide by v, which gets really complicated though when there's already a division over here. Let's say there's some sort of division over here, and when you divide both sides by v, suddenly you have a fraction divided by fraction, which you can solve using the fraction rules. But instead, I like to sometimes say we're going to multiply by the reciprocal of v. What's the reciprocal of v? Well, v is v over 1, and the reciprocal is just when you flip those fractions. It's 1 over v. So I must multiply 1 over v over here, and we can see that the v's cancel here, and I'm left with time is equal to d times 1, d, and d is essentially over 1 times v, v. So that's why I like multiplying by the reciprocal. You might say, why, Peter? Why didn't you just divide by v on both sides? And that'll work, but if you have a weird equation, let's say you've got, this is just a made-up equation like this, distance over time. Let's say you've got a situation like this, and I want to get mass all alone, and I divide by v here. I must divide this whole thing by v. And it will confuse some students. Some students will put it just here, which actually ends up working fine. And so if you're good at that, you understand. But in reality, it's dividing this whole fraction. Now, clearly, they cancel out here. But here, you're left with a fraction. You're confusing. And if you make your bar too short over here, you're not sure which fraction was what. Was it t divided by v or d divided by t? But we know that it's d over t divided by v. And we know technically v is over 1. Well, the rule of fractions is you take this fraction and you multiply it by the reciprocal of that one. And that's why I say, why don't you just multiply by the reciprocal in the first place, and you end up with the same result. But I like just multiplying. So if I'm in that situation, I can just multiply. Instead of dividing by v, I can just multiply by the reciprocal on both sides, which is what you have to end up doing with fractions anyway. There you go.